Okay, so now we'll see what we mean by an inertial frame, because that is something that is required for a better understanding of Newton's laws. So we call it an inertial frame. It comes from inertia, or something doesn't move. So let's consider that, well, first let's say that an inertial frame is one. By frame we mean like where you're considering the thing. So this classroom is a frame of reference. So or the surface of this earth is a frame of reference. If you're inside a car and that car is moving, that car would be your frame of reference, and you'd measure everything with respect to yourself, and yourself may be moving in the car because the car is moving, and you may be going straight, you may be curving, but that becomes your frame of reference. So your frame of reference, whether you're in a car or a truck or on the road, may be inertial or may not be inertial. So it is inertial if that when no external force is acting on it, is acting on any object inside your frame, on an object in your frame, when no external force is acting on your frame, there is no acceleration. In that object. So that means that if you don't have any force, the object doesn't move. So it doesn't appear to be always like that. So let's take a few examples. So let's say you're in a bus and you're standing in a bus, and you take a soccer ball and you put it on the floor. So that's your ball, and the bus is stationary. So when you leave it here, it will just stay here, and so there's no force on it, or maybe there are forces on it, but there's no net external force, and the ball just stays where it is, and you stay where you are, and the bus stays where you are. Okay, so that's very simple. Let's go to the next one, where the bus is going towards the right with a uniform velocity. So you're going at a constant speed in the same direction, and you're standing in the bus, and you put a ball on the ground and let it go. Now what happens to the ball? Does it stay there, or does it start moving? Well, because if you're going at a constant velocity, the ball should just stay there. And you know that if you're going in an aeroplane, you're in an aeroplane, and the aeroplane is going pretty fast, and you're inside it, and you have a glass of water that you put on the front seat, on the back of the seat, and the plane is going at a few hundred miles per hour. So that water will just stay there. Or you can get off and walk around in the plane, and you won't be thrown away, because the plane is essentially an inertial frame. This is an inertial frame, and this is very similar to this. If it's going at a constant speed, it's also an inertial frame. So both of these are inertial frames. And this one also. But now let's consider a case where your bus is accelerating. So here the speed was, let's say, 20 meters per second, and now here your speed becomes 30 meters per second. So from here to here, the bus has accelerated. And now if you release that bus on the floor, it's going to roll backwards. And you know that feeling. If you're standing in a bus and the bus starts accelerating, you are also pushed backwards. So if you're holding on tight and you're just standing there, or you're sitting, and what you would appear to you is that there is a force acting on this object that's causing it to move backwards. Otherwise, why would it move backwards? From within your frame of reference. Now, for a person standing outside, it'll be different. But for a person inside the bus, you will see the ball start rolling just by itself. And so, apparently there's no external force on it, but in this particular frame of reference, the ball has an acceleration. And therefore, this is not an inertial frame. And then if the bus applies the brake and it slows down to, let's say, 5 meters per second, so the bus applies the brake, then we would expect the ball to start rolling forward. And that's what happens to things. Even people lurch forward because it's no longer an inertial frame, and you do have a motion even without an applied force. Well, within that frame. As seen from somebody outside the frame, it would be different. So an inertial frame is one, essentially, which has inertial frame itself has no acceleration. So long as your frame is stationary or moving at a constant speed, a constant velocity rather, then you have an inertial frame. When your frame is accelerating, it is no longer an inertial frame. Now, the surface of the Earth, if you're standing on the Earth, let's say here's the equator and here's the North Pole and the South Pole. So this point is moving, well, they're all moving towards the right because the Earth is going in a circle. So if you look at it from above, here's the North Pole and this is the equator. So you're seeing the Earth from above the North Pole. Then the Earth is going around like this. And circular motion means the direction of the velocity, which is going this way, here's going this way, here's going this way. The direction of the velocity is changing, and so you have an acceleration. The surface of the Earth is therefore not, very strictly speaking, an inertial frame. However, the acceleration is very, very small, almost zero. It's not zero, but it's very, very small. And therefore, for most purposes, we can assume that the surface of the Earth is an inertial frame. And we are living in an inertial frame. The surface of Earth is an inertial frame.